Good morning, everyone. Welcome to this first session of the day. Thanks for getting up as early as you do. I know for some of us it might not be the usual time. Before we go, so this talk will be about mobile architecture at scale, about how we built and how we built an app or an architecture that we're developing with over 100 engineers on the same code base. I'll talk about why we're doing it, why we need 100 engineers, and so on. But before I jump in, just to get a bit of feel for you guys, how many of you are native mobile developers, iOS or Android, if you wouldn't mind putting up your hands? Okay, how many of you are doing mobile development in any other platform? And how many are just doing other things that may be back-end development, other engineering, or anything else? Awesome. In terms of company size, how many would you mind putting up your hands if you work at a company that's small than 50 people or so? Yeah, and then for the rest of you, I'm guessing that'll be more than 50 people. Great. So with that in mind, I'm pretty sure you're going to be taking a bunch of stuff away, especially on the larger company side. The things that I'll be talking about will be about mobile. If you haven't done mobile, I'm hoping it'll still make a lot of sense because I will not go into the trenches of the mobile code itself, but rather the thoughts and general things. And just a little bit of background about myself. I'm an engineering manager at Uber. I've been with Uber for about a year and a half, but before, for about 10 years, I was a software engineer. I started on the Microsoft .NET stack. I had a Windows Phone stint building a couple of apps there. WCF, that's where I learned a lot of my kind of architecture knowledge. The .NET framework design guidelines was one of my biggest influences. And then later on, I moved over to do mobile development, web development, iOS, and then Android at Uber. And I've actually been, I'll talk a bit about that. I've been a bit surprised on what architecture means on mobile and how little, or sometimes it can feel a little bit more shallow, but I'll get into that and why. But why architecture is important. So we'll talk about three things today. We'll kick off with the motivation of why we decided to do something very different at Uber than the rest of the industry, especially with mobile developers. We'll talk about architecture, why we ended up building a new architecture and why we didn't seem to see that the things out there worked for us. And then I'll talk about something that a lot of you can take away is how do you scale an architecture or even an idea at a big company to have everyone use it the way they should. So I'll kick off with the motivation. So in terms of motivation, I'll talk a bit about Uber's history, or more the app's history, how the architecture grew, and how we got to this point where we decided to do a rewrite, and why we did a rewrite after a couple of years. So how many engineers does it take to build Uber? I get this question all the time, and the answer is it's about one or two. This is the Uber team back in 2011, building, I think, the second version of the app, because the first one was built by contractors, and we threw it away, started from scratch. That is the whole team, busy releasing the latest feature. I'm not sure if it was credit cards or whatnot. So things have changed, as you know, and Uber has grown exponentially, especially in terms of engineering. So you can see that in about 5 years, we went to having one full-time engineer to about 100, and this is, mobile engineers. I'm not talking about any other, this is only mobile engineers. And a lot of engineers, especially if you're the mobile, you're thinking of, what, 100 mobile engineers? Like, why would you need that many people? From my previous experience, I worked at a company where we had about Skyscanner, we had, on one app, we had, about 10 engineers max, and that was a really big team, and we had some really big challenges there. So why 100? Well, at Uber, you need to request a ride. That's what we call the rider app. Then there's a driver side, where drivers also have an app, and they need to do a bunch of stuff, as you can imagine. Well, Uber, it turns out we're about, this is rough, I don't have the exact, I'll check the exact number, but we're in about 80 countries and about 600 cities, and in every city we have different things, in every country we have different regulations that we need to do, so there's a bunch of extra stuff there. And then we're not just Uber anymore, but we have things like, so we're not just a kind of taxi company, but we have things like Eats, we now have Fright, we have some self-driving things where we also have a mobile app. If you ever get into self-driving car, you'll see an app in the back seat that shows you a bunch of stuff and you can interact with it. But And these things are not as simple. When you request a ride, like sure, you connect the rider with the driver, but there's a bunch of other things that are going on. For example, you can now schedule a ride. I just did when I came to the airport. You see a bunch of news items, which you might not seem that important, but they're doing a bunch of things. You can split the fare with someone. You can, in the US, you can have a family account and check on your team, where they are, track them like in a good way. You have airport pickups, yada, yada, yada. It all adds up. And all of these are typically the responsibility of different teams, so that you will have a mobile engineer who is responsible for this experience on one app or the other. For drivers as well, we have things like Uber Beacon. In the US, you have those little glowing things. You have the cash experience. How do you make sure you can pay with cash? And a few people know, but in India and Latin America, you can actually pay with cash for Uber. We have Uber Pool. Maps are super important there. And again, it starts to add up. Same with being in so many countries. We now have a bunch of engineers, so now we have a dedicated team, for example, for app performance, who measures how fast it does, what are our critical bottlenecks, fixing those things, or networking, making sure we work well in low latency environments, and so on. So it starts to add up. And then, of course, we have separate apps for Eats, Fright, etc. So it kind of all comes together. So Uber, whenever you open Uber in a different country or even a different city, you might get a slightly different experience. We do have features that are only specific for one country. So that's the answer. That's why we have a lot of engineers. And again, it does start. If you want to build a simple Uber app, it is, one engineer can do that. So the app has grown over the time. It started. This is the app about maybe like 4 or 5 years ago. You didn't have too many options. You could say pick me up. You could select maybe the vehicle type. That was a big improvement after the initial ones. And then we start to add more things. You had a bit more vehicle types. We had to be a bit more creative around how you did that. You could edit your pickup location. Again, more features came in, and things starts a bit crowded. You might not see, but things are barely fitting. You can barely read it, but it was kind of okay. And then again, more and more things started to come up. More teams came putting in their features, kind of cramming them in, and the map starts to get smaller and smaller. And we got to this point of that we call the where to moment. There is an actual screenshot where this is the whole app in a smaller device, like that is the map, and I'll just zoom into. There's so many things going on there. These are all features, the SOS features, and it says swipe down for what. You can't even see what exactly was. So this was a point when the design team decided, or the product team decided, like this needs to stop. Like we're cramming everything, and Uber should be about you getting from A to B, not about these. It's turning into like a newspaper, or like in a really bad way, like a tabloid. So this was a point when the design team and product team said, like, let's just change everything. Let's change how the app works, and let's start clean. Let's make sure the map is in front. Things are. We sell the features, but they're kind of more contextual, whatnot. So at this point, the engineering team was like, sure, that sounds great. What does this need? What does it mean? We had an app architecture that was based on MVC or MVP, on different platforms a bit different. We're like, well, we need to change all the views, obviously. We need to change their sequence, so we need to change a lot of the business logic. Like, we can keep some of it, but practically, like, we'll have to like throw out about 50 or 60% of the code. And I mean, if you do that, that is a rewrite. So we're like, okay, so we actually need to do a rewrite. It's not that we're asking for it, we have to do it. So we said, cool, if we do a rewrite, well, let's take an opportunity to do a proper rewrite. Let's not just keep building what's happening, but let's address maybe some of the engineering things, the challenges that came with architecture growth. So so now let me talk a bit about like what pain points we had with architecture growth. So in the Uber app, when we started, maybe even before this version, but roughly our architecture was like this. We had, I'm going to talk about Android, but this is generic to iOS as well. You can replace activity with view controller, or you can just think of, if you're not doing mobile development, just a component. We had a logged in activity. That was it. Well, okay, not entirely, because after a while, this is a bit too big to be one class or one activity. So we broke it up to have, a menu, a location. Like a menu was there, that small thing, you could expand. Location controller, let's say a product selection. So like a couple of components, and then these components had some sub-views, sub-components. So that was our initial architecture. It's pretty nice, pretty simple. We try to make sure responsibilities are clear. We used again something like MVC or MVP, which I'll touch on. But as the architecture grew, we saw some issues. One of them was, how do we store state? So here, based on your selection, that is like a separate component. Based on what you select, that little guy will show something different, and that might be a different responsibility. So those things had to communicate, and the easiest way to communicate things is via state. So that's what we introduced. We said, hey, at the logged in level, at the parent level, let's have some sort of state that this guy knows about it. It somehow collects that data. So whenever you would swipe something, you would modify that state, and the other controllers would know it. Great, this worked pretty well. So that's what we have. We started to share state between components, and it worked pretty fine. But when I tell you, this was our architecture, I'm a bit lying, because this was really our architecture by this point. Like, as you add more things, your parents start to grow. But by small things, but it starts to become bigger. And as we start to add more things, it starts to become even bigger. And then we had that state lingering around. So I'll get to the point on what this actually meant in terms of biggest problems. So when we came to rewrite, we actually sat down and said, honestly, what are our biggest problems? Because it seems, it's not as fast as it used to be. Like with the three-person team, it was faster. And our number one problem was actually the number of engineers. We had 100 engineers by this time, all working on the same app. And that is the crux of it. From my experience, I see architecture is not really important when you're a small team. For one person, you can have the most complex app in the world in one function, or maybe one RX chain if you want to make it really hard for the next person. But it'll work. With a team of 3, you want to have some things kind of figured out who does what. With a team of 10, you kind of want to understand who puts something where. But we were at 100, and we were following all these best practices, and still. One thing that we saw is people no longer understood how the whole app works. Like, they understood parts of it, but a new person joining, it took them forever to figure out a lot of stuff, and they made a bunch of mistakes. They started to introduce a bunch of bugs because they were not aware of things like state, like what state existed, and I'll talk about that second. And modifying the app started to get slower. So, that joke, or when if your product manager is like, what takes so long to add a button? We got into a situation. It wasn't adding the button that took a long time, making sure that we didn't break anything on the way. So what does state have to do with this whole problem? So let's say that kind of a half hypothetical, but somewhat practical example. We wanted to build a small component that would show kind of a notification when your driver was on the way. So you open the app, you say, all right, search for, request a ride, you get the kind of loading indicator, and when from the server you get this notification that the driver has accepted and started going, you get this little pop-up. Now the code for that was something like this, and it's not about the details, but I just want to highlight, it's a bunch of code. But the most important part of what we wanted to do, we just wanted to have a component that could show a notification saying it's on the way, and we could tie it in. And we have a bunch of stuff around state. Because we had a global state, we needed to make sure, if the trip has already changed, we have a trip level state that the trip has kind of updated that we know that the driver is on the way, then we show this toast. But if you already started the trip and you get this backend message, you don't want to deal with that, so you don't want to show it, and then you have to store some local state. Now, we had to do a lot of this stuff because we had this trip state, which was just none of this component's business, but everyone has to know about it because you will break other components. So instead of this, we had to write something like this. And this was just one example of how whenever we added a new component, instead of being something simple and one responsibility, it had to know about the rest of the app. Which led to the other problem, modifying the app. Let's say we wanted to add a new kind of component or module. Normally you would just add this component and you're done. Well, in this case, you obviously need to modify the parent as well. But that's not really true, because now we actually needed to either modify or test every single one of the siblings. We need to make sure that these things all work. Now, I mentioned that Uber works in 80 countries now, and back then it might have been only 40. But a lot of the bugs that we saw happening was, oh, something broke in India. What happened? Oh, well, the US team added a new feature on Uber Pool, and it just broke the UI in India. What happened? Well, they didn't test in India, and they didn't know about it. So it just started to become slower and slower and slower. So these were our main pain points. So we're like, great, we can start from scratch. the design is saying us we can rewrite. Our CEO, back in the day, Travis was saying, like, we need to rewrite, our history, our future depends on it. So we're like, great. But before we jumped in, so like, all right, slow down. Let's set some goals, like, because, let's just not rush into this thing. Before we set some goals, I just want to highlight some things that, as Uber, as a company, we had as constraints and opportunities that not all companies necessarily have. Our number one constraint was that we needed to stay native. The reason for this is two reasons. One is we're a partner to Apple and Google. They bring the latest features. They actually come to us and say, hey, you guys need to do this, or can you do it? But it's like we sometimes, we pretty much want to do it. It's a mutual beneficial relationship. We're at that size. And then the other reason is we don't want to give up control. So performance is a huge thing for us. We have a whole team looking at performance and how we can optimize the trenches. If we go with something like Xamarin, React Native, whatnot, we are giving up control for that third party. We could, of course, invest in them and help that better, but going back to the first point, we do need to support new features often before they're out, often before they're public, like a couple of companies where, who would be kind of launch partners, it would make it more difficult for us. So we decided we're saying native. Like, we need to be native. It's not a question. Native on iOS, native on Android. The second important thing is we decided to have independent iOS and Android code bases. We wanted to have that native app, and we wanted to be able to change them independently. An example is we wanted to add Android Pay for Android, Apple Pay for iOS. And there might be some small, like, we want it to feel the same, but we want to reserve the right to have it different. Because of this, building something that generates code even inside of us for the two apps, we didn't really want to do it. So we have separate repositories for those. What are some things that I think Uber was lucky to have, or I was lucky to have it be at Uber, to be a company that has it? Well, we have something called the mobile platform team. At Uber, we call a platform team kind of a team of developers whose only job is to help other developers in the company. It's like they don't, like this is like the cool team. This is like the people you hire to build cool stuff, cool tools for developers. They are the ones who build frameworks, they build performance tools. Like their role is, like their job is help other developers be more productive or better at the company. So that's pretty cool. Few companies have that, companies like Facebook, and above a certain size you have it. Uber had this pretty early on, which helped us with the rewrite. And then finally, we had something called a monorepo. So unlike a lot of places that use pods and whatnot, you pull it from different repositories for components. We had all our source code for all our iOS apps were in one repository. And we had a separate team who made sure that the build times were really fast. So we would optimize the Swift, we would try to make our compilers better. So the opportunity here is that we didn't need to worry about all the tooling. We just said, like, hey guys, our build is slow. Can you do something about it? And a couple of engineers would work on it day in, day out, and they would just make it faster and integrate with our build tools for our for Xcode or IntelliJ, etc. So that's pretty cool. All right, let's get back to like what do we want for this rewrite? Cool, we have this really great team to support us. We need to stay native. All right, what should we do? Number one thing is we want to get isolation and testability. When I show that diagram of like I add something, I have to modify everything, we want none of that, or like as little as possible. Can we just like have everything do one thing and one thing only, and be testable as well? We want our developers to be productive. Let's not get slowed down. And this is a bit harder to measure, but we want to put that as a goal there. Next, we knew we're at 100 engineers. We knew we would be at like 200 engineers in a year, and so on. Like, can we do something where we just don't have to rewrite again? Like, is it possible, please? A next one was a bit specific to Uber, but every app of a certain size can empathize. We wanted the app to always work. Like, at Uber, like we update the app every week, and bugs will go out there. Like it's the more engineers you have, the more it is. We want important to always work. How do you say it should always work? Well, what we said is let's turn it into something measurable. The core flows are the things where like it's the most important. When you request an app, you request an Uber, you get an Uber, you use it. Like we wanted that stuff to always work. That other stuff, updating your profile, whatever, that can break sometimes. It's not great, but it can. And we said like 1 out of 10,000 sessions should only have an issue, and that's like 99.99. So we're like, let's measure that and let's make sure that it works. And finally, two things we want to have, and this is again when you're big enough. We want monitoring to be a first-class citizen, not an afterthought. It was an afterthought, and we wanted to make sure that we could experiment, run A/B tests without crashing, everything. Whenever you use the Uber app, we have a lot of experiments running similar to, like, let's say Facebook or whatnot. So you might see some things that other people don't. You're helping us figure out if things work. So thank you, and sorry. And finally, as we talked about all these things, we realized, hey, we have this iOS team, we have an Android team. Wouldn't it be cool if we could do something that was kind of similar? Again, we have separate code bases, but in the past, the iOS app had an MVC architecture, Android had an MVP, we had a bit different structure, we had the same features, but teams didn't really talk. We're like, can we do something that's just have our engineers talk and do something at a high level similar? So those are our goals. So how did we do this? Again, we had a mobile platform team, so we had about 5 to 8 engineers for about 6 months, practically, well, for 3 months, locked themselves in a room, and they started to prototype everything. Like, they took the core part of the app, requesting a trip, and they prototyped some things. How can we do, like, think of building to-do apps just for Uber, seeing, does this work, does this look good? Some of our really experienced engineers. And they came up with a core architecture. Like, all right, we can build on top of this. Then, so this was in January, in about June, we had the first team who's building this kind of core experience, the driver team, come in and for them to actually test it, like I build this core flow, which is requesting an app. And then they came back and said, they started to do that, and they realized, like, this is terrible, this is missing, we need to do this. So for a couple of months, we iterated on it and made it better. And then the rest of Uber, so this is like at this point about 20 engineers, the other 80 engineers joined in, and we told them, you need to, this is where I actually joined Uber a bit earlier, but this was my first ever project as an Android engineer. And yeah, in about 4 months, we just rewrote the whole app. Like, we literally froze the existing app, we rewrote everything in a pretty quick pace, and then we released to the App Store. And that's a different story, because we did a hashtag YOLO release. We replaced the iOS app with the new one. And we thought there would be, like, the adoption was really fast. So we thought we had like 1% of people on day one. We had like 20%. So it was a pretty fun and exciting launch, and scary in some parts. And that's rewrite done. Well, that seems really simple. It wasn't entirely. I'll get into like what we've learned. But what I did learn from this one is when you set like a hard deadline for deprecating an app, it's nice, it's also a bit stressful. What did we build in the end? So we built 2 things. We built a RIBS architecture, and I'll talk about RIBS is this architecture that we built, and I'll go into details about it. And we built an application framework. So RIBS architecture is the thing that like, we have pretty generic things that anyone can use. Things around testability, about how we do routing, code generation, components. An application framework is more specific to Uber, about our monitoring infrastructure, how we use our networking, some of our UI components. We open source the RIBS architecture because it should be usable for other people. For the applications framework, we might open source parts of it, but some of this will never be useful for anyone. Like, we have a custom monitoring system, so that component will talk to our APIs and all that, so it's not going to be very useful for you. So that's the motivation part. Let's get a bit more kind of hands down on architecture. And when I say hands down, like, not necessarily all the way to the code, but we'll have a bit of that as well. So how do we approach architecture? And before I talk about how and why we designed RIBS, I want to talk about 2 really important things on architecture that's really important for every client application. And you might not, we learned this the hard way, but this is, I believe, when we think about architecture, we should always think about state, and we should also think about dependencies. We should take these into account. In the past, I didn't. So let's talk about the state management problem. We did a diagram of the old Uber app, which was, again, built by about 100 engineers, on what state transitions occurred. And it was horrendous. Like, no wonder no one understood the app. It was a lot of these transitions in the middle. They're around when you go on trip. When you accept, so many things can happen. The trip can end, the price can change, you might get notifications, et cetera, et cetera, et cetera. So yeah, it was not great. And we're like, all right, so we had a lot of states going back and forth, like, how can we simplify this but make it easy to understand and easy to modify? And then, of course, like, when it comes to graphs and all those things, one of your simplest data structures is a tree. So we asked, like, can we just represent our states like a tree, something like this? And so we started to sketch it out, and like a simple tree, like ideally, making it. And it seems that everything that we did here, we could just map it to a tree. So we just kind of took most important part of the app, which I'll talk through to this one, like you're logged in or you're logged out, and it kind of seemed that it would work. So we're like, all right, let's give this a go. So how what does those states mean, or how does this work? So let's talk a specific example. Let's say you start the app, you have this root component, whatever that might be, and you're logged out. You see like, all right, you need to log in. You enter your username and password. This component then makes a request to your backend, which then returns a response. And then this component says like, cool, you're no longer logged out, you're logged in. I'm just gonna show another component, like I'll replace you and I'll get rid of you. And that's kind of the idea. It's nothing rocket science. This is very generic, nothing to do with mobile. So we're like, cool, let's use this model. Let's just have these like pretty simple components, and then we can try to break it up into logical pieces. So this is what we did. We built the app based on state, what can happen. And it mapped pretty well to our UIs, actually. So this was before we built the new app, but we already mapped it there. So for example, all of these, and I'll show where they map. But one thing we noticed is, in the past app, we only thought about screens. Every single component had a UI. These no longer all had. So there were some parts that didn't have any UI. So for example, we were thinking it makes sense to have something called request, which its only job is that if it listens to our network saying, are you on a trip or not? And if you're on a trip, it shows this part. If not, it shows that part. And we felt it kind of feels right that it has its own thing instead of just being part of this like logged in state, because it makes things a bit more clear. And like our UI parts, like our menu is there. We have a location editor. We have a feed card, shortcuts. But again, we felt that these three should be owned by a home component, because it's only shown when you're there, and it should have some business logic around manipulating these, expanding them, whatnot. So we're like, okay, well that looks pretty okay. Let's go with this. So we thought we have a solution for the state problem. So what about the other big problem we had was scope. So I mentioned that like we had this thing where in our previous app we had this scope that everyone knew about, like the whole app knew about. And we were thinking that caused a lot of issues. So that was the problem of why whenever you made a modification in one of those components, you needed to know about the state of the whole application. So we're like, can we just limit that? Can we do this thing where, let's say when you're logged in, like this root component knows that you're logged in, and it shares this scope with only the logged in child and of course itself. And let's say that you go you go to your home settings, so you're not logged in. We share that scope with only the children. And then let's say that you go on a trip and we share this kind of scope only with the children, and so on. So. And whenever, let's say, you switch between, like, I'm no longer on a trip, but I go back to home, you kind of get rid of it. And what we saw is with this, we would have a lot shorter-lived scopes, which would simplify our state, which would lead to simpler components. And I'm going to show you a demo to you and what this means, these whole components mean. But it seemed this model would work pretty well and make things pretty simple. So these are the two things that we took is, like, we wanted to have some architecture that can support this tree structure with non-visual kind of state, like nodes, if you will. And we wanted something where we could have this hierarchical scope where a parent can pass on kind of information to his children that they can use and modify, but it will only be used for that part of the tree, and it will disappear later if they are kind of die. So before we jumped into, we said, like, let's not reinvent the wheel. What is out there? Like iOS and Android world, give us what you got. So we went through all of these things, and I saw some people put up their hands. They're not mobile developers. So I'll just go through a few things that it should be familiar from other things. So in mobile, we have MVC, MVP, MVI, MVVM, and then Viper and bViper. And I'll actually just do a quick run through of what these are. MVC, who knows about MVC? Put your hands up. Great. All right, let me tell you about mobile MVC. It's I guess it's similar to MVC. So in mobile, it's or client-side development, you want to know where the input comes from. It goes to the controller. The controller then manipulates the model and updates the view. It's kind of the brain of everything. And then the model, the view also usually subscribe to changes on the model. So view observables usually. It depends, again, this is like a really rough outline. But that's roughly MVC, and if I'm terribly wrong, pull me aside afterwards and tell me that I'm wrong, but that's kind of my idea. And with MVC, by the way, there's so many flavors, so it can be different. In the mobile world, we have something called MVP, Model View Presenter. This is especially popular on Android because on iOS, for some reason, MVC actually works more like MVP, but that's a different thing. So instead of a controller, we have a presenter. And the difference here is your inputs go straight into the view. So when you type on a text box, it goes into like the view part. The view will then, the presenter will subscribe the observables to changes to this view. So it'll have a kind of a self-dependency. It starts to update the model. Again, it listens to the model being updated, like if everything changes, and it manipulates the view. So the dependency change, it's a bit nicer, and responsibilities are a bit better defined. And the direction of data flows is again a bit more straightforward. Then we have something called model view intent. This came from the JavaScript world, and it's became pretty popular in Android for certain applications. And the idea here is like with MVC, there was a bit of a mess. The controller did a lot of stuff, and it just became this huge bottleneck. But it was a nice idea. So what if we still had the input go into this thing called intent, which manipulated the model? The model then actually manipulated the view, and the view updated the intent. So like whenever you would have any events go on, it would do. And it works pretty well. It has things like reducers. So on the intent, you would have a lot of the idea of reducers, again, from JavaScript. And it works well for some applications. So there's that part as well. And then there's MVVM. Can you put your hands up if you know of MVVM? Yeah, so I mentioned I started WCF, WPF. I grew up on this, but I personally love MVVM because of the fact that layers don't need to manipulate each other. So again, you will know input goes into the view knows about the view model, it updates it. The view model knows about the model, but on the way back, it's just kind of a binding or it's a self-dependency. So. With these, I'm pretty sure there might be a few more permutations, but you get the idea. All of them are a little bit different, but they share some common things. And then when it comes to mobile, most apps are built on these, and they work fine. They work great. For some bigger apps, some people said like, well, this is difficult, and the most difficult part in mobile is routing between screens. Almost every time, these views are either a screen or a controller, but how do you do the routing? And at a platform level, routing is weird in iOS compared to other client-side things. And like in JavaScript, in web, you don't need to worry about it. So some people came up on iOS with this concept of Viper. And this is taking MVC or MV whatever to the next level. It's got this thing called interactor, which is kind of the brain. It's got the business logic. So the inputs will go into, well, the interactor decides, all right, I'm gonna manipulate the data, my data source, my entities. It then also talks to the presenter, where the presenter is this kind of layer between the view. It then manipulates the controller, listens to the view, it listens to changes on the view. It will tell it will tell the interactor what kind of stuff to do. And then finally, there's this thing called routing, which is where all the screen transitions happen. The big idea behind this model is really the routing, and it kind of splits the view into two parts. There's a presenter and a view controller. It works pretty well for big apps because you move your routing logic out, you make it clear what your business logic is, and you split your view logic into two parts. So it's nice. What all of these share is they all have a view tree. Like every single thing, you do have a view there. And I mentioned that in our case, we were thinking, can we not have a view? Also, the business logic and the view trees are tightly coupled. So your app structure will be whatever your view structure is, pretty much. And then finally, we started to experiment. So again, I said we were part of the app. We're thinking like, how can we share this kind of state, like so that it's only short-lived, which we call kind of with deep school hierarchies. And you can do it. You can have these short-lived states, but they need to be based on your views again. So there was consistently, we're coming for every single one of these architectures. There was this limitation. It was a problem for us, and it seems it would stay a problem if we stuck to this. So going back to Viper, this Viper was originally published as a code example and an article, and then some people started to really use it and like to use it, especially big companies with lots of developers. It's nice and separated. But someone came up and said, like, hey, it's not really reusable. Let's make it reusable. Let's add a builder that turns this whole thing into a module. So we actually kind of like this whole idea of Viper, and it was all separated, but some things felt off. But this was the architecture that inspired us the most. And so we built ribs, and what ribs are is, again, the names will be different, but the function will be important. Ribs are just an interactor, a router, and a builder, so like business logic, routing logic. And then in some cases, well, a lot of cases, but we have a presenter and a view similar to Viper and some of the others, but these are optional. Like you cannot have it without this. And so the way ribs works is the interactor, again, is kind of your business logic. It will make some data requests to the presenter. Hey, present this data or do whatever with it. The presenter, we actually make it optional. We often don't have presenters. We go straight to the view because usually this layer doesn't do much, actually. So we just skip it. But it will, if needed, it will translate to the view to understand what to show. The view will, via some UI events or some binding, let the presenter know, like, hey, what's happened. And then the presenter will also make some business logic calls to the interactor. And then finally, when things are done, the interactor says, all right, route. The big difference with ribs is routing does not happen between screens. They happen between components. And I'm going to show a demo of what this is. So with the demo, I'll go into a bit more details on how these work. But ribs are just sounds for router, interactor, builder. And yes, you can have a presenter and a view. So how does this, let's go back to original example of like what we planned. Hey, let's have this kind of a state tree with visual and non-visual parts where we have that menu component, location component, feed curve component, and shortcut components. So we build this with ribs. Every single one of those is a rib, router, interactor, builder, and it might have a presenter and a view. So how does that actually work in practice? And I'm gonna, instead of doing a live demo, I recorded this. We have this pretty neat tool where we can see our rib tree on how it changes. And I'm just going to show how, when you use the app, how these components or ribs change all the time. And first, we'll just go back and forth, and you see that whenever you change things, like the rib tree updates all the time. And so here, what I'd like to show is, let's go on a trip. So when you went on a trip, suddenly we threw away every other previous kind of tree, and we have that thing is called a trip router, a trip component there. So once we go on the trip, we'll see some new components pop up on the screen. There we go, we're on the trip. So I'm just going to pause it for a second. So as you can see, as I say, changes, we kind of, it's like if you do, it's like a DOM inspector. Like we add and remove elements. And the difference with the DOM inspector potentially is that these elements also have scope. So this parent will pass its scope down to its children. So whenever this is removed, that state is destroyed, which is awesome because a lot of the bugs happen when you have kind of leftover state and things happen in the background. And what I'm going to show here is when we cancel that trip. Like, yeah, you can see we go up and down, we have new elements come in, and we add it, and then we don't remove it for a while. We could remove it for memory optimization. What happens when we cancel the trip is this whole tree is going to be torn down. So let's cancel it. Yep, let's confirm we cancel it. And our tree has completely changed. We go back to our previous tree that was there. So that's how, just the kind of visual representation of how these ribs actually do work in practice pretty well. All right, and let me go to the next slide. Oh. Hello. I have to go through the whole video, it seems. I'm sorry about that. I am stuck. All right, so that's how the components update and work. One thing I didn't talk about, and I kind of just left it on the side, is this is the architecture with ribs, just you don't need to understand it. And this is what bViper looks like. A big difference that Viper and every single one of the architectures had, they had like a model or something about data. I didn't talk about that. Why is that? Well, with ribs, we didn't make the model part kind of per se part of this. We're not subscribing where you should or you shouldn't use it. You should probably use it in the business logic, by the way, with the interactor, but we didn't subscribe. But in practice, what we do with ribs is well, specifically for Uber, and a lot of mobile apps do the same thing, is we have this kind of stream-based data approach, and you can do something different, so we don't describe it, but this is just to share what we do, and it's a nice practice. So the interactor will make like a network request to a service, like, hey, fetch me this, and this is, most of the mobile apps are online driven, so, and that service will send a response saying, hey, I've started, but I'm not, it's not the result, but we can show the loading indicator or whatnot. Then that service talks to your services, it gets the response. It doesn't give the response straight to the interactor, it gives it to a model stream, which is typically an Rx stream, immutable. And this interactor listens to those data models, it gets updated, and then it starts to tell the presenter, hey, update yourself. It updates the view. The view might return a UI event, which might turn into some more business logic calls, going back to the service or not. And at some point, it just tells the router, all right, navigate or do something. So that's how this whole thing fits in there. But that top part is not. We're not trying to be opinionated about it. You can do whatever you'd like there. If you want a plain old common object, you can have a plain old common object. And finally, on the architecture, I said one big difference with RIBs and with all the other architectures is we do specifically think about viewless states that don't have any views. And why would you have that state? Because you just basically take away all this stuff. Like, why would you have a component like that? It's only two classes. Well, it actually, in this case, all that the main responsibility beyond doing some sort of business logic is attaching and detaching children. And does that make sense? And I'll show you why it does make sense in another demo with this inspector. So here, you will notice that when you have UberX or UberBlack, those are all things that I believe you can schedule. But you cannot schedule an Uber van because we have so few of them that they don't work. So right now, UberX is selected. And now, when you're selecting an Uber van, like, oh, something happened, so we'll look at that again. So when you select the Uber van, that little scheduled write thing disappears, but then it appears. And as you can see, that's tied to a component right there. So there is this component here that is responsible for laying out all of the child components. It has an extra responsibility. This is the viewless component. That doesn't show any view. We have a couple of UI elements here, but it has the business logic to show or hide this thing based on the selection. And it works pretty neat. You get to, by having these viewless ribs, and Google's site is failing on me again, so we'll see if once we see it, we can go to the next one. But by having these viewless ribs, you can make your business logic a lot more clear, and we have a lot of them in our application. Again, your mileage might vary. All right. No, I'll have to step out and step in again. Cool. So that's the architecture part, and now I'm just going to close with some of the lessons that we learned scaling in architecture. So we built this really cool architecture with these like 4 or 5 different classes. We have some ideas on how to use them, how not to use them, how these viewless things. And a team of, well, when I say we, a team of about 5 or 10 people built this, and we had 100 people to use it. So how do you adopt this? How do you make sure people use it and they use it the right way? Don't use it like don't use it like MVC that you're used to. Don't use it like MVP. Use it in the correct way. And when I talked to the guys, and I also saw it firsthand, adopting any framework or any new idea or any architecture pattern, it's a bit like this. Like, you do your best to herd cats, you do your best to tell people, but every one of the developers, they're really smart, they know what to do, they're opinionated, they love to do workarounds that they will not tell other people, and so other people will discover. So it's hard. We did find a few really important things that you should do, and like, next time any company open sources an architecture, I'd love to see some more of this, or not even open source, but just use it. First, do code generation. Like, best way to make sure your code looks and feels the same, have it be generated the same. Second, think about your onboarding, how you're onboarding people, and then finally think about how you enforce these patterns. So I'll go through this one by one. Code generation. When this team came up with this idea, the reason I think it was so successful is when they kind of gave access to the other 100 engineers after the initial thing, they had some code generating templates. On Android Studio, they said, like, if first day one install this thing, or we had it pre-installed, generate a component, it throws out all the code that you have, all the boilerplate, and it's kind of with a lot of comments, add your business logic here, do not do this, etc. And we did this for iOS and for Android. Actually, it's a lot less work than it seems. I talked to the guys, they're like, oh, wow, you're so cool, you built this, how long did it take? Well, yeah, it took us like an hour. Plus, you need to know how to do it, so you need to look it up. But they're pretty simple. I ended up open sourcing this part of the application. I never did code generation on either Android or iOS. I just did it. And in any modern IDE, it's easy to do. So next time you want to adopt something, do a code generator. People will thank you for it, and it will make it easier. And we open source this one. Second was onboarding. Whenever you have this new architecture, you kind of assume like it's easy, people get it. But how long does it really take to learn a new architecture? And I think it takes a lot longer than you think. Now, when you have 100 engineers, you start to notice these things. But actually, like when we had a new guy join our team, we showed him, explained to him. I didn't talk for an hour. I talked for 2 or 3. We thought he knew it. And a week later, he came back with questions. Then we reviewed his code. He wasn't doing stuff. It took a long time, like at least a couple of weeks, like a month, so that he really knew how to use this. So what do you do? Well, if you have a bigger thing, definitely do some documentation, especially like we're in a team in Amsterdam. I'm based in Amsterdam. We work with the people in SF. Like it might be easier if you're local, but then you're kind of just shielding the problem from when that person cannot talk to you. So do good documentation. And then one thing we started to do after a while, because at Uber we had people join literally every week, and we had to show them again and again. We started to do tutorials on how does this work. We put together example apps. Now we did this because we're big enough, and we had to onboard again. We onboarded at least 50 or 100 engineers on this last year, and it was tiring to do the whole sessions. And then we ended up encouraging contribution. At the end of the tutorials, we said like, hey, does this make sense? Your first task is to fix this tutorial because it's probably outdated. So we kind of got a little bit of loop. And then we also open sourced all of our tutorials so as part of open sourcing this architecture, we're giving the code generation and the tutorials, and it takes a good while to go through it. Like if you properly want to invest in it, it'll take you like, I don't know, like from a couple of hours to like a week, depending on your pace. Cool, code generation, good, people can onboard. How to make sure they actually do what we want to do, and that's a tough one. At Uber, we started doing something really early in the company, which is lint rules. Initially, we did use lint for, spacing and all that. Turns out you could code like architecture patterns in there as well. So this rule says that, for example, if in a view controller, if in a view component you invoke this add child controller, don't do that, you get a warning. It's like, and we have tons of these, and it's pretty easy to add to our linting rules. So like people, whenever we have an architecture discussion and we have an agreement or disagreement and we come to a conclusion, we often just add a lint rule. When you try to check in code at Uber, it's so hard to mess it up. It will literally tell you cannot do this, and then sometimes you disagree with that. So I'll get to that at a point. The other super powerful thing we have, how many of you have used a tool that supports blocking code reviews like Fabricator? See some hands up there? Some of you don't have it. Fabricator, well, blocking code reviews are awesome. At Uber, we use Fabricator. So what this means is you create a pull request, or in Fabricator, we call it diff. Teams can kind of specify, for every file or every folder, you can say, if this code is modified, I want to know about it. I want to be blocking code reviewer. Being a blocking code reviewer means you cannot merge that pull request until that person says yes. So in this example, with the screenshots you'll see, I created a change for like the payments, and immediately, which touched some core Android code and some payments code, immediately 2 blocking reviewers were added, and I cannot proceed without them. And this is all automatic. Of course, as part of this, your culture needs to change, because now I can't wait for those for like a day, and they need to respond. But it's really cool. The experts are reviewing your code, but only when you change that part of the code. It also encourages you, if it's not, think about it, do you really need to change whoa, I did not realize I'm touching some really like sensitive code here, like maybe that was just like, I was refactoring that part, maybe I'll skip that for later. It works very well. And it scales very naturally with the team. If a team stops doing these blocking code reviews, they just get taken off after a while. Like this only works until you have a team developing things, so it's nice. And then finally, like, what if you disagree with a lint rule or something? We're trying to make it easy for people to change the process, change the architecture. And we're following something called an RFC, the IETF does this for the World Wide Web. It's a really long and difficult process, but we're doing a super light version. You have an idea, or you want to make a change, or you want to build a product, you send a summary, like a one-pager or two-pager, to all of Uber engineering. You say, like, literally, here's what I'm doing, here's my plan. That's it. It works like a charm. So it's like a fire hose of information. People start commenting, and you sometimes add approvers, and so there's this discussion going on. And if you're, if you work like at Uber and you're really big about, I don't know, .NET, you will read and you might have a filter for anything that has .NET, and when someone talks about .NET, you'll want to jump in and you'll want to give your 2 cents, and sometimes even say, like, we should not do that, and it goes offline. So we have a pretty good way to, and we've changed our architecture and things a lot with this, and we're now working on a new one. So let's say you do this. You have code generation, you have onboarding, you enforce your patterns. Like, does this mean you can adopt your framework? Yes and no. You're missing one really important thing, is ownership. Whatever new thing you do, framework, architecture, methodology, whatever, if it doesn't have an owner, it'll die. Like people will follow all these things, and then no one will care about it. So in our case, we do have a team who owns this thing, which is why I honestly think it works. Otherwise, it would not work. They're driving this. They're interested in this being a success, in being developers, making developers productive. So yeah, just make sure that team, and you have a long-term owner. If you work at a big company, this typically means talk to your manager saying, like, hey, this is our responsibility. We can't just do it on the side. It's going to die. That's how a lot of company open source ends up going to. All right, so how did ribs work out for us? This is just closing it up. We have 3 apps with more than 200 developers using this architecture. One of them is the rider app. Some I can't be too specific about them, but we're in the process of getting them out there. But we have about 200 developers using it. We have more than 600 ribs, like these components, and a lot of them are reused within the app or between the apps, which is pretty cool. Almost all classes are less than 300 lines of code, which is nice. Now, a rib does have like 4 or 5 components, so in total like 1,500, but it's pretty cool that it's a small class. Because it's so small and kind of simple, almost all of our business logic is really well unit tested. We measure percentages, but it's just more the important stuff is tested, which is cool. And we open sourced the ribs core architecture, so you can check it out if you're interested. So we use this for a year. We open sourced it about 2 months ago. What did our engineers say after a year of using it? So this is, I'm not going to take the positive feedback. I'm going to take about what the criticism that we got and that we're working on. The number one thing is we had this really cool, you can split the app into pretty deep hierarchies. Well, it turns out number one feedback is like it takes and it's coupled with dependency injection. Whenever you want to add like a new service or something for your component to use, like let's say you need, I don't know, you need a calendar service, like down to add your calendar thing. You have to add it through the whole tree, and it takes a lot of manual work, and it's just annoying. So that's the number one thing. It takes a long time to add or remove these dependencies. Partially, it's intentional. Like, don't just add random stuff, but we're thinking of maybe adding some tooling for that. Developers are saying we're generating a lot of boilerplate code. Like, even with, we don't have to have a view or a presenter, but it's still a lot of code, and code is memory footprint, code is unnecessary to read, so we're thinking, how can we make it even more lightweight? Like, can we make it a bit more configurable? For some cases, you build something really complex, you need a lot of boilerplate, you're gonna use every bit of it, but for a lot of times, we have classes that are almost empty. And then, from iOS, iOS has this thing called view controllers, which is like this heavyweight views, and we don't support the lightweight views, and this goes back to allowing things to be more lightweight. And at Uber, we care about the app download size because we see it affects how many people add it. So again, it goes back to just allowing things to be simpler. So the main feedback is it's good, but it could be more lightweight. So we're working on that for our next version. So is it an architecture like ribs for you? And I would say if you have an app or even a similar approach, if a client-side application that has lots of non-visual state, you should think of either doing something like ribs or thinking about, does your architecture work well? If you have a fast-growing team or an app, again, you want to invest more in architecture. Architecture does not matter for or it matters so much as for small teams, it matters for big teams, and especially if you know you're going to grow for sure, you might want to invest early. And finally, do you have the bandwidth? Like, I'm not going to pretend this is a simple architecture. By bringing this architecture, instead of using some existing thing, we need to do onboarding. It still takes a bunch of time. People, don't understand necessarily. They will make mistakes with it. They don't know. It's a lot of extra bandwidth on the team that built it. They get a lot of questions on the developers. So we're asking a lot for people to do. Is it worth it? Like, if you're doing something that's similar to what your competitors are doing, it might not be. Maybe talk to them, ask what they're doing. And yeah, and so wrapping up with that, so in this talk, I just went through like our motivation, why we had to rewrite our app, and that was a pretty cool opportunity. Just as closing, I think Uber got lucky in that sense. We're a big company that grew, and we had an excuse to rewrite our app. Some companies that have similar challenges include Facebook, maybe Twitter, some of them. I don't think they had this opportunity. So from talking, and this is really interesting because when you have this, you look at things very differently. We had an opportunity to look through a different lens and have the excuse for a couple of months to just rewrite. And then I talked about architecture, how we looked at the architecture, why we were looking for something specific, something that supports these kind of non-visual states, something that supports nice state management, and how we came up with RIBS, which supports all of this. And then finally, what we learned by taking this architecture, having 100 engineers, 200, and having them use it. And do tooling, do code generation, do linting, do documentation, think about tutorials, and make sure someone owns that thing to make it a success. So I'll wrap up with that. Thanks very much for your attention. You can check out this architecture, and again, even if you're not a mobile developer, you might get some ideas on how to approach architecture, how to drive change, how to decide when is the right thing to look things through a new lens. You are all working in different businesses. Sometimes you get into this point when you're building something very different that's out there. A lot of times, I used to assume everything is already done. Why should we reinvent the wheel? And sometimes it's not about reinventing the wheel, but just solving your problem in a way when you take a different trade-off. So with that, thanks very much for your attention. I hope this was useful, and I'll be sticking around for questions.
Hi, can you tell something about the flow and management of information between the product design and the product management and the development groups? How do you coordinate that?
So was the question between product management and?
Yeah, for instance, if the product team decides that we have to need these new features,
yep.
The design team need to come up with some suggestions, and development teams know how to coordinate between each others.
Yep.
How does that work?
Yeah, because Uber is growing, a lot of the things we do goes back to this idea of sharing information pretty freely and having these kind of proposals shared. So what we do as a product team, they typically work with engineers saying, hey, we need to do this is a business request. Let's say we need to support, this new Chinese payment type or something. They might talk with their development team initially. They put together a plan, a proposal saying, here's what we're going to do, here's a high level. They work with developers, designers, and maybe data scientists, put together a plan, and then we circulate it to the whole company, saying, here's what we're planning to do. Developers also see that. And then once people agree, like, yep, that's the right thing to do, developers often come in and say, like, well, have you thought, are we thinking of the SDK? Have we talked about this vendor, they're using that, etc.? And once we have a sign-off, then it goes to developers, and developers put together an architectural plan, like how are we going, we do have a brainstorming session, we write stuff on the wall, and then we send out a document. Again, we might get feedback, but if in a really fast-paced project that is totally new, no one knows about this, you talk with the product team, they send out a paper, people don't care, people don't know. Your team goes on, they send, here's what we're going to do, people don't know, you just do it really quickly. If it's something where everyone is opinionated about, for example, Kotlin. We had this idea, which is not a product one, but someone said, let's do Kotlin. And it went out, and so many people jumped on it, so many people had it. Some people worked at Facebook, some people were on the Kotlin team before, and it became this really long argument, because it turns out it would have been really risky to do it. So I'm not sure if that answers it. It's a mix of spreading information. We don't necessarily drive to consensus. The product manager can make a decision to move forward. People can voice very publicly saying, I think this is a terrible idea. And we have had that. It's pretty funny. Sometimes on these documents, you see directors comment saying, like, I think that's a terrible idea. We should stop this right now, and we should have a meeting. And you're like, and then someone says, like, all right, let's have a discussion. And you see, like, as an update of discussion, we are still agreeing to proceed. So yeah, it works. It works pretty well. Sometimes you still make decisions which, in hindsight, a person still has a lot of influence, and the team still has a lot of influence, which I think is good. If you think of from a having sign-off, ever has the information, not everyone might agree. So we have an opportunity for a disagreement, and we usually address that. Hope that answers. All right, with that, I suggest we wrap it up. I'll be around if you'd like to grab some questions. Thanks very much for your time. Enjoy the rest of the day.